I won't take much of your time. This is the last work package, so the last scientific one. So it hasn't actually started yet, so there's not much to show in terms of work already done. So I'm gonna present it more in the terms of what is expected from each task. Okay. So this is advanced measurements for numerical validation. So the objective is quite straightforward. So what we want to have is a powerful database of experimental work, hopefully with high quality, able to provide the numerical guys tools to validate their own numerical models. Okay, so that's the main objective. So in terms of innovation, we have a few points. One of the most important ones is the 3D pilot scale. I think it's something we all look forward to see happening. In terms of structure, we have 5 different tasks. The division is quite straightforward as well. It's mainly related to the scale of the tasks to be performed. Okay. So we have quantification of the microstructure. Then we have the effect on materials at the sample scale, at bricks. We have the subsystem scale, so wallets or walls. Then we have the pilot laboratory scale, which is the 3D pilot model. And then we have the measurements, in-situ measurements on the actual still lab. In terms of date, so this work package should start in the middle of this year and should end in the middle of 2021. So the first task related to the microstructure, we have tests expected at these 3 different locations, at Limoges, Aachen and Leuven. 3 different students. These are some of the tests they are expected to perform. Okay. The second task is the thermal gradient effect on materials. So this is the sample size or brick. We have tests expected at Limoges and Aachen, 2 different students as well. These are some pictures of examples of tests. These were not tests actually performed at this point. Then we have the subsystem scale, so small walls or large walls. Here we have 2 main the contributions in terms of institutions. We have RHI Magnesita. I apologize for leaving only RHI over there. And my university, my research group, so University of Minho in terms of ISIS, which is University of Minho and part of University of Coimbra. And here we have the biaxial compression test at RHI Magnesita. And we have the tests on uniaxial compression on walls. This is sorry, not this one. Here. So this is the large vertical furnace we were discussing just a moment ago, the 3 meters wall. So it is we can test walls up to 3 meters, but in this case without any mechanical load, so only thermal load. Okay. But we can do smaller walls, and we can have it with thermal load and mechanical load at the same time as well. So we have a lot of experience with the general mainstream, so in both experimental and numerical studies. We're quite good at that. In the specific case of refractories, this is actually a new field for us, so we are looking forward to learn a lot of new things. So this is here we have a lot of different possible combinations. We can have joints with mortar, without mortar. We can have it with thermal load on one side, on both sides. We can have mechanical load as well. We can have constant or a gradient. We can have mechanical tests after thermal exposure or at the same time. So we have a whole field of possible combinations. And we also have brick tests as well. Then we have the 3D pilot model, which is one of the innovative parts. So this test will be performed at Tata still, with the collaboration of those 3 ESRs. So this is quite a new thing, I think, for all of us. And then lastly, we have the in-situ measurements on the Tata still level. So here a moment ago we were discussing what kind of measurements we were going to have. So we're still debating some of the measurements, but this is mainly as the whole work package, to validate the numerical models developed in work package 3. Hopefully the result won't make the guys from work package 3 having to change the parameters too much to match the result. So this work package the connection is quite easy in theory. So we should get a lot of information from work package 1 in terms of measuring techniques, testing, acquisition protocols, innovative acquisition methods, those kind of things. So we should get that kind of information. And we should also get some information from work package 3 as well. So we're gonna need some information from the predictive modeling in terms of the overall behavior, so we can calibrate the acquisition systems and the loads and those kind of things. And the main result will be providing work package 3 with the experimental results for the numerical validation in different terms, in the overall behavior, in the strain or stress fields, thermal fields, displacement fields, and so on. So that's it for work package 4. Any questions?
Just a small remark. In the wall furnace, we can apply, and we should apply at least a serviceability load on the wall. We can do that, and we should do that.
We can apply what? Sorry?
A load, a serviceability load.
Okay.
Because without load, it's not realistic.
No, when I mean mechanical load, I mean, for me, mechanical test is until collapse. So in this case, in that furnace, we cannot do because the wall is too big. I'm assuming the values needed to collapse the wall are extremely high, and I don't think I'm sure we don't have the equipment.
What would be the maximum load you can apply?
It depends. For the smaller walls, I think we had this discussion a while ago in a co-supervised master thesis on normal masonry, and I think it was something like maybe 1,000 and something kilonewtons, I think, because we have the actuators, but we need to move them to the place where we have those smaller furnaces. So we need to play around with the size of the wall itself, because if the wall is too big, we need a higher load. So there's a lot of things we need to address and to refine, let's say, before the actual test. One interesting topic I was just discussing with Cido as well, and Alain and Joao, is that we have a lot of experience building the specimens ourselves, but for normal masonry. So we don't have any experience in building refractory masonry. So probably there's a different protocol, a different technique and procedure. So we also gonna need some training in that sense, just to make sure we do it the right way. So yeah. Any other